Welcome to This Week in Biochar, where we bring you the hottest topics straight from the readers of Biochar today.
I think this week is a really fascinating mix of real world applications and then also some research that's kind of making us all think a little bit more deeply.
Yeah, I love it when those two things collide. It seems like we see that more and more in this field. So let's dive right into our first story. And this takes us to a poultry farm in Denmark,
Okay.
where researchers are testing out biochar's potential to combat a very common foodborne illness.
Right. They're looking at Campylobacter, which is a bacteria that causes quite a bit of trouble,
Yes,
especially when we're talking about poultry and just food safety in general.
absolutely. And they found some pretty impressive results.
Yeah.
Adding biochar to the chicken feed
Okay.
resulted in an 80% reduction in Campylobacter.
That's huge.
That is a big deal,
Yeah.
especially when you think about how widespread this problem is.
Mm.
In Denmark alone, they're reporting thousands of cases of campylobacteriosis each year.
Yeah, and that's just the reported cases, right?
Yeah, it's just the tip of the iceberg.
Yeah, a lot of people don't go to the doctor.
Exactly. So it really makes you think twice about that next chicken dinner.
Yeah, it does, but this study offers a lot of hope.
Yeah.
For sure.
I think what's so compelling about this particular study is that it wasn't done in some, sterile lab.
Right.
This was done on a commercial poultry farm.
Yeah, a real working farm.
Which, adds to, the legitimacy
Yeah, exactly.
of this solution.
It makes it seem like, okay, this could actually be applied
Yeah.
on a larger scale.
Absolutely. And, this is where it gets even more interesting for me because, biochar
Yeah,
is made from organic waste materials
right.
through a process called pyrolysis,
Exactly.
which essentially means you're heating that biomass in the absence of oxygen.
Yeah, you're just cooking it down
Yeah,
until all that's left is that stable carbon.
right. So you're taking something that we would normally think of as waste
Yeah,
and turning it into this valuable product.
exactly. Turning waste into a resource.
That has the potential to improve food safety.
And maybe even sequester carbon?
Yeah, that's the holy grail, isn't it?
It is. It's a win-win.
That's what we love to see.
Yeah, for sure.
But, speaking of carbon sequestration,
Okay.
our next story kind of raises some questions about biochar's ability to really do that.
Yeah, this one kind of threw me for a loop.
Yeah.
I was like, wait a minute.
Because we hear so much about biochar
Right.
being this amazing carbon sink.
Yeah, it's going to save us all.
I know, right? But a recent field study is saying not so fast.
Not so fast. It might not be as stable as we once thought.
Okay, so this study was conducted in North Florida,
Yeah.
and they found that biochar carbon losses were anywhere from 17.5% to 93.3% per year.
Per year. That's a lot.
93%. I mean,
Like almost all of it in some cases.
like it's disappearing before our eyes.
Right. Where is it going?
So what's happening here?
Well, the researchers think that it's primarily due to decomposition.
Okay.
They were very careful to make sure that biochar wasn't physically lost from the study site.
Right.
So it really seems like those microbes are just having a feast.
So the climate in North Florida,
Yeah.
the heat, the humidity.
That's a subtropical climate.
Yeah.
It's perfect for microbial activity.
Right. So that could be part of the problem, that it's just breaking down that biochar much faster.
It's like leaving your compost pile out in the summer sun.
Yeah, exactly.
It's just going to break down really quickly.
And, it highlights the importance of doing this kind of research
Absolutely.
in a field setting.
Real world conditions.
Yeah, because in a lab,
It's a controlled environment.
right, we can control all those variables.
Yeah, exactly. You don't have all those microbes and the fluctuating temperatures.
Exactly.
You don't have all the things that you find in a real ecosystem.
Right. And this study also revealed another interesting finding,
Oh, yeah.
something called positive priming.
Positive priming.
Have you heard of this before?
I have. It's a pretty wild concept.
Okay, break it down for me.
So basically, the presence of biochar in the soil can actually stimulate microbial activity,
Okay.
and that can lead to faster decomposition of the native soil carbon.
So it's like we're adding kindling to the fire.
Kind of. It's a bit counterintuitive.
Yeah.
If we're trying to sequester carbon, we don't want to be speeding up the decomposition of the carbon that's already there.
Right, so it's like a double-edged sword in a way.
It is. It's definitely something to consider.
Yeah.
It's not all sunshine and roses.
And it's why I love this show, because we're not just like,
Right.
biochar is the answer to all of our problems.
Yeah.
We're really trying to look at it.
The good and the bad.
Yeah.
The critically.
And speaking of real-world complexities, our final story this week takes us to Ludlow,
Okay.
a town in England,
All right.
where plans for a new biochar plant have hit a snag.
Uh-oh.
So let's talk about what's happening in Ludlow and why there's this pushback.
Yeah, it seems like a good idea on the surface, right?
Yeah,
A new biochar plant?
but the town council has
Yeah.
raised some concerns about the potential environmental impacts.
Yeah, they're worried about things like increased traffic and noise pollution and odor.
All valid concerns.
Definitely.
Yeah,
And especially when we're dealing with a new technology like this, we
right.
have to be extra careful.
And there's also some history here.
Oh, really?
There was a biodigester facility at this same location
Okay.
that caused some problems in the past.
So there's already some distrust.
Right, there's a sense that the community has been burned before.
Right. They're like, we've seen this movie before,
Exactly.
and it didn't end well.
So, it really highlights the importance of transparency and community engagement when we're talking about implementing these new technologies.
Absolutely. We can't just force these things on communities. We have to work with them.
Yeah, and it's not just about alleviating fears,
Right.
it's about actually working together
Finding solutions that work for
to
everybody.
find solutions that benefit everyone.
Yeah, exactly.
So, wow, this has been quite a deep dive already.
It has.
We've gone from food safety to carbon sequestration
Right.
to community concerns,
A whirlwind tour of the biochar world.
and we're just getting started.
That's right. We've got more to come.
So stay tuned because in part 2, we're going to delve even deeper into this fascinating world of biochar research.
It's going to be good.
We'll be right back.
After a short break. Welcome back to This Week in Biochar. We're picking up right where we left off.
Yeah, my mind is still kind of swirling from that North Florida study.
Yeah.
Those high rates of decomposition really challenge the idea that biochar is like this guaranteed carbon sink.
It definitely makes us think twice about some of the assumptions we've been making.
Yeah, so let's unpack this study a bit more. What exactly were they looking at?
Well, they were testing out biochar made from a variety of different biomass sources,
All
like
right.
oak, pine wood, and grass. And then they were also looking at biochar produced at different temperatures.
So not all biochar is created equal.
Not at all.
That makes sense. Let's start with the biomass. What did they find there?
Well, the biochar made from grass decomposed much faster than the biochar made from the oak and pine.
Why would that be?
It has to do with the chemical composition of the biochar. So grass biochar tends to have a lower degree of aromatic condensation, which basically means it's more vulnerable to those microbes.
Ah, so the more complex and stable that biochar structure is,
Yeah,
the better it's going to hold up against decomposition.
exactly. It's like building a stronger fortress
I like that.
to keep those microbes out.
Okay, so then what about the production temperature?
Well, that was really interesting, too. They found that biochar produced at higher temperatures, 650 degrees Celsius, was significantly more stable than the biochar produced at lower temperatures.
So hotter is better in this case.
It seems that way.
It's like you're forging a stronger shield against those decomposers.
Yeah, that's a great way to put it.
So it seems like we're starting to get a more nuanced picture of biochar. It's not just this one-size-fits-all solution. We need to think about the source material, the production method, and even the environment where it's being applied.
Absolutely. And that complexity is what makes this field so fascinating.
This all ties back to that concept of positive priming that we were talking about earlier.
Right.
It's not just about the biochar itself, but how it interacts with the entire soil ecosystem.
Exactly. And that's where things get really interesting. The introduction of biochar can stimulate microbial activity in the soil, which can lead to faster decomposition of both the biochar itself and the existing organic matter.
So it's this balancing act.
Right.
We want biochar to improve soil health,
Yeah.
but we also need to be mindful that it could potentially speed up the breakdown of that existing carbon.
It's a delicate dance.
It is, and that's why these field studies are so important. They give us a glimpse into how biochar actually behaves in these complex environments.
Real-world data is invaluable.
Absolutely. We need to see how biochar interacts with different soil types, climates, and microbial communities.
It's like observing a forest over time.
Yeah, we can't just take a snapshot and think we understand the whole picture.
Exactly. And as we gather more data, we can refine our understanding of biochar's potential and its limitations.
All this talk about microbes reminds me of something I read recently about biochar's potential use in filtration systems.
Oh, yeah, that's a fascinating area of research.
So how does that work?
Well, it turns out that biochar's porous structure makes it an excellent filter for removing contaminants from both water and air.
So it's like a natural sponge that can soak up all the bad stuff.
You could say that. And it's being explored for a wide range of applications, from purifying drinking water to treating industrial wastewater to even cleaning up air pollution.
It's amazing to think that something as simple as charcoal can have such a profound impact.
It really is, and it just goes to show the versatility of biochar.
It seems like every week we're discovering new and innovative ways to use this material.
And that's what makes this field so exciting. It's constantly evolving and pushing the boundaries of what's possible.
But as we've seen with the North Florida study and the controversy in Ludlow, it's important to approach biochar with a balanced perspective, acknowledging both its potential and its limitations.
We need to be cautious about making ground claims and ensure that biochar innovations are implemented responsibly with careful consideration for the environment and the community.
And I think that's what makes this show so valuable.
Yeah.
It's not just about hyping up the latest biochar fad. It's about having an informed and nuanced discussion about the science, the challenges, and the opportunity.
Absolutely. We want to empower our listeners to think critically and engage with the complexities of this field.
Well said. So on that note, let's move on to our final segment, where we'll explore some of the cutting-edge research on biochar's role in promoting soil health and plant growth.
Sounds good. Let's dive in.
Welcome back to This Week in Biochar. We're wrapping up our deep dive, but I think we've saved the best for last.
I agree. We've talked about some pretty fascinating research and real-world applications, but now I think it's time to look ahead.
Okay, so what has you excited about the future of biochar? What are some of the emerging areas of research?
One area that's really gaining traction is the interaction between biochar and soil microbiology. You know, those tiny but mighty microbes?
We've touched on this a bit, but I feel like we're just scratching the surface.
Yeah, there's still so much we don't know about those little guys. They really are like the unsung heroes of soil health, and their relationship with biochar is complex and fascinating.
So what are researchers trying to figure out?
Well, they're investigating how different types of biochar influence the composition and activity of those microbial communities.
So does adding biochar create like a microbial party in the soil?
It can, but it's not a one-size-fits-all party. Some microbes thrive in the presence of biochar, while others might not fare as well.
So it's almost like creating a custom-designed ecosystem.
Exactly. And the goal is to figure out how to optimize biochar applications to encourage the growth of those beneficial microbes, the ones that enhance soil health, nutrient cycling, and plant growth.
This is where it gets really interesting, right? It's not just about adding biochar to the soil and hoping for the best.
Right.
It's about understanding that intricate web of interactions between biochar and the soil microbiome.
It's like conducting a microscopic symphony of life in the soil.
And that's what I love about this field. There's always something new to discover.
Speaking of discovery, another area that's generating a lot of buzz is using biochar in filtration systems.
We talked about this briefly earlier, but I'd love to hear more. How does biochar actually purify water and air?
It all comes down to its amazing porous structure. You know, it acts like a natural sponge with countless tiny pores that can trap contaminants.
So it's like a super efficient filter.
Exactly. And the potential applications are huge, providing safe drinking water in developing countries, treating industrial wastewater, even removing harmful pollutants from the air we breathe.
It seems like every week we're finding new and innovative ways to use biochar.
And that's what makes this field so exciting. But as we've discussed throughout this episode, it's crucial to approach biochar with a balanced perspective. We need to continue the research, especially those long-term field studies, to fully understand its potential and its limitations.
And we can't forget about the importance of community engagement. As we saw in Ludlow, implementing biochar innovations in the real world often means addressing social and environmental concerns.
Absolutely. We need to work together to ensure that biochar is used responsibly and sustainably with the support of local communities.
So as we wrap up this week's deep dive into the world of biochar, what's the key takeaway you want our listeners to walk away with?
I think this biochar is not a silver bullet. It's a complex and multifaceted material with incredible potential, but it's not a quick fix. We need to approach it with curiosity, skepticism, and a commitment to responsible innovation.
Well said. It's a journey of discovery, and that journey is just beginning. I can't wait to see what the future holds for biochar.
Me too. It's a truly fascinating field.
And that concludes this week's episode of This Week in Biochar. Thanks for joining us on this exploration of the latest news and research in this ever-evolving world of biochar.
Until next time, stay curious and keep exploring.